screen. Yeah, can everyone see my screen?
Yep, that's come up now.
The kind of a big red curtain. All right. We also have a few people online. Sarah and Effie. Yeah. Can you hear me? All good? For people online? Okay. All right. Again, I'm recording this session. Feel free to raise your hand or call out in the room. Lydia will come to help you. This is the second week of SCB 113 RStudio workshop. Again, if you have time, fill the attendance form at the end of this session. So today we talk about how to process data in a spreadsheet format to make it ready for analysis. The data is like the new field. It's valuable, but only useful when it's kind of refined, get rid of the noise, something, and then make it in the format we like. I have emailed everyone who registered this workshop a copy of the presentation. Have you received it?
Yep.
PDF copy?
Yes, everyone's got the copy now.
Excellent. Yeah. Because I'm afraid the emailing function of UniHubs that may not work. It's okay now this time. So okay, we have used this data set a few times. If you remember, the Star Wars character data set. Now let's use it again. Now we know that the raw data of Star Wars in the tidyverse package is quite messy. It has 14 variables, 87 rows, which is a small data set, which is very small. But suppose we're only interested in some of the variables, okay? We are not interested in the other messy variables, okay? And then we want to recode the data into the format we like. So suppose we want the name of the characters. We also want the sex group, and want the sex group to show value as F or M, but rather than female and or male or something. And then we want the height to be in centimeter, and then we don't want anyone taller than 2.2 meters. Okay, for some reason. Okay, we just want this, and then we want the body weight showing the variable name as weight rather than mass. It's already in kilogram, I think. And then we also want to delete the rows that have missing values in any of the three variables, that is sex, height, and weight. And then we also want to create a new variable, imagine. Okay, imagine we want to create some variable called BMI, body mass index, which is the weight in kilogram divided by the square of height in meter. Okay. And then sorry, I made a mistake before. We want the height in meter rather than centimeter. The original data is in centimeter. Okay, yeah. And then we also want to create a binary variable we call size, and then we define it as this way. So if the character is taller than 1 meter and heavier than 75 kilograms, we call this guy big. Otherwise, small. Okay, so suppose we want to process the raw data, the messy raw data, into a neater, smaller data frame with only this 1, 2, 3, 4, 5, 6 variables, and then in the format we prefer. Okay, so like this: name, sex, height, weight, BMI, size. Okay, yeah. So how do we do that? It's quite it's relatively easy if we use the tidyverse functions to process the raw data or wrangle the raw data or data wrangling. Okay, so how do we do that? Let's do it together in RStudio. So I'm launching my RStudio now. RStudio.
All of you have R installed? Yeah. Have you installed the tidyverse package yet?
Yeah, I guess most of them have. We had a first session in orientation week for some people, and this is the third session for most of them, I guess. I'm still recording. Good. All right. All right. So again, as usual, you should check your working directory. Okay. Okay. If you need to. Okay. So now I just start a new file, a new R script. So now, first of all, I'm going to library tidyverse. If you haven't installed this, you have to install this package first. But I guess most of you have installed it already. So library it out. Highlight run. It will take a few seconds to load the package because it's a big package. See the red button here, the red light here. That means it's loading. Okay. All right. I get some warning message. Don't worry, just warnings. That reminds me the version is a little bit old. It's okay. I'm okay with that. So we know that in the tidyverse package, there's something called the Star Wars. I got a hint. Star Wars. There's a data frame included in this package. And if you view it, we have done that before in the last couple of weeks. It's this data set, right? 87 rows and 14 columns, 14 variables. Some variables are kind of redundant. We don't want it. And then lots of missing values, and NA that get the missing values. Okay, yeah. All right, and then we're going to use this tidyverse functions to convert or process the raw data into a smaller, neater data set we prefer. Any question in the room or online?
No, should be good.
Should be good. Okay, let me just have a quick look on any. Okay, good. All right. Now, first of all, I need to introduce a new operator in tidyverse package. It's called the pipe operator. So it's like it means and then. So you do something, you do something first, and then you do something else, and then something else. So you can connect multiple steps of operation using this pipe operator. It's a percentage symbol, right arrow, and then percentage symbol again. Okay, this pipe operator. It means and then. Okay. So let's do this. So we load this tidyverse package, and then I'm going to create a copy of the original Star Wars data set or data frame. Is here. So I call this one SW_need. SW_need. This will be the neat, clean, smaller data frame we will create in the end. Okay. So first of all, it's just a copy of the raw Star Wars data set. Okay. And then, it's this one pipe operator, and then percentage error percentage. I'm going to select these 4 columns. So I want the name, sex, height, and mass. So they are the original 4 columns or variables in the original Star Wars data set. Okay, so this one select is the function to choose or keep the variables you want. Okay, so select means I only keep these 4 columns: name, sex, height, and mass. And then the order you put here will be the order in the result. So I put the name first, and sex, and height, and mass. Then the order in my resulting selection will be the column name first, and then the second column will be sex, and then height, and then mass. Okay, yeah. And then I use this little function called the na.omit. We know na means missing value in R. So this is a simple way to delete the rows with missing values in any columns in the data set. So after selecting these 4 columns, and then I na.omit, I will delete the rows which has missing value in any one of the 4 columns. Okay, yeah. So as long as there's a missing value in name or sex or height or mass, this row will be deleted. Okay. This may not be the best way to deal with missing value, and there are many ways to deal with missing values, which is beyond the scope of this workshop. It's also beyond the scope of SCP 113. I just show you that the simplest way is just to delete the rows we don't there is missing value. Any questions so far?
All following up to this point?
Okay, all right. And
Yes.
then
One question.
One question, yeah.
So with comments, we can just intersperse them throughout the code and still run it as usual.
Yes. So put it either at the beginning or end. Don't put it like in them. Don't do like NA omit hashtag no, then your brackets, but just at the end of that and the and then symbol or before it is good.
Yeah, if you want to do this, I mean.
So see how these ones have hashtags here? Those would be comments in the code. So if you were to
the
like
hashtag is comment.
this, that's how the comments would appear. So how they're placed there is a good indication.
Yeah. Yeah. So what I do is I use the pipe operator to connect multiple steps in one piece of code. This is my one piece of code. Okay. And then if you do it separately, and then for each function you have to tell the function the data set and then comma, and then the like a select have to put a SW_neat and then comma, and then put these 4 columns in there, which is, I think you have a kind of examples in your SCP 113 computer practical sessions. That's how they did it in that sessions, but I'm doing this differently. I'm doing like a okay, I have a copy of the original data set, and then I do this step by step, and then I connect all the steps into one piece of code using this pipe operator. So in each step, I don't need to nominate the data frame name anymore. It all comes from Star Wars and then to the copy, and then in the following all the following steps, I'm operating the copy of the data set step by step. So I'm kind of the first step is choosing only 4 columns of the copy, and then second step, I'm deleting the rows with missing values in these 4 columns. So at this stage, after deleting the missing values, the number of rows of SW_neat will not be 87 anymore. It's probably 50 or 40 something, because there are many rows they have missing values in those 4 variables. And then I'm going to rename mass as weight. So you put a new name first and then =, old name. So the original name is mass. Now I call it weight. Okay, I rename mass as weight, body weight. And then I use the mutate function. Mutate function is quite useful in tidyverse. You can use mutate function to recode a variable. You can also use mutate function to create a new variable. So here I'm basically recoding the height. So height will become the original height divided by 100, because originally height is in centimeter. I want height to be meter, so the height will be height divided by 100. Okay, and then I use filter function. Filter function is to choose and keep the rows you want. The first one, select, is to choose and keep the columns you want, and the filter is to choose and select the rows you want in the spreadsheet of data. So in the filter function, there must be a logical evaluation here. So if only the rows that have the true value for this logical evaluation will be filtered out and kept in the operation. So the evaluation is, I want the sex to be equal to either male or sex equal to female. Okay. And I want the height to be no taller than 2.2. Yeah. That's the criteria. Okay. Combination of two criteria. Sex to be either male or female, and then height being less than 2.2. Yeah. So I keep only the rows with sex value being either male or female, and not taller than 2.2 meters. Yeah. I also in this notation, I also have there's a different way to write this piece of code. You can also write like this. Okay, filter sex in this little vector. Okay, and height less than 2.2 meters. Yeah. Any question at the moment?
Good. Okay, I think we're good to move on.
Yeah, for people who have a little programming experience, this may look a bit challenging. Yeah. All right, almost there. And then we use mutate again to recode the sex. Remember, original sex values are male, female. We want the male to be F and female to be capital M. So that's how we do recode. Okay. So recode, there's the variable, and then there's the new value. Sorry, the old value to be new value, capital F, and the old value recode it to be a new value, capital M. Okay. Yeah. And we use mutate function again to create a new variable called the BMI. BMI is equal to weight divided by height square. This is a height square, right? Remember, height has already been recorded as a meter in this step. So weight is in kilogram, height is in meter now. So BMI is weight divided by height square. And then I use mutate again to create this variable called the size. Remember the binary variable of size we want? Some are big, some are small. So this is the size. You can see here, first of all, I make size equal to a logical evaluation again. So height over 1 meter and weight over 75 kilogram. So in this step here, the size that the new variable size will be either true or false according to the evaluation here. Height over 1 and weight over 75. So at this stage, the values of size will be either true or false. And then I use size equal to if else function. So if size is true, then we give the value big. Otherwise, if the value of size is false, we give a value small. So this is little if else function. We will talk a little bit more about programming basics in R in week 7 or 8 something. Yeah, in a future workshop, we'll talk about programming, how to control the logic flow using if else. This is one way to do the if else. So if the criteria is true, you give a value. Otherwise, that means it's false. You give the other value. So this is the if else.
Do we follow with that point? Do we
It
want
could be.
that point rephrased, or is everyone good with that?
Yeah,
Yep.
okay. I'll just go through this and then we'll do it together. And then Lydia, you may need to work around. I'm pretty sure there are some questions. There'll be some
Yep.
questions. We run the code. Okay, and the last step is after all the recoding, I want to sort my data, sort those rows by sex alphabetically. So the females will be first, and then male rows will be in the bottom. And then also sorting by BMI in descending order. So large BMIs will show up first, and the smaller BMI will show up later. Okay, so let me go to my RStudio. This is the original data of Star Wars. You know, you see it's messy. And then I'm going to run this code. Hopefully we get what we want. Okay, so copy, Control C, RStudio, Control V. So be careful when you are copying code. Just pay attention to the double quotes, because the double quotes may not be in the format preferred by our language. So I just retype double quotes here. Okay. The double quotation marks. Any other here? F and M F and then big and small. Yeah. All right. Let me just go through it first. Quickly select, omit, rename, mutate, hide, filter the rows I want, male, female, and lower, smaller, shorter than 2.2 meters. And then record the sex values, female as F, male as M, and then BMI, and then size, big, small. Then arrange the rows according to sex and the descending order of BMI. Okay, highlight all of them. And then click run. Hopefully there will be a new object called SW_need in the global environment. And then it has the web, it's in the format we expected. Run. All right. That's the first time it runs without any errors. Okay, so you can see we have no red warning or error message in the console, which is good. And then there's a new data set called SW_need in my global environment. And let's double click to view it. Okay, double click. This is the SW_need. You see it has 53 observations, 53 rows, and 6 variables. That's the 6 columns we expected: name, sex, height, weight, BMI, and size. And it seems it shows the value we want, and no missing values. First of all, that's why the number of rows reduced from 87 to 53, because we deleted all the missing values, the rows with missing values. And that sex as a male and female, height in meters, weight instead of mass, BMI, it looks like BMI values, and the size values are small and big. And that is sorted by sex first, so females first, and then males, and then in descending order of BMI. So BMI, large ones first, 27, 21, 19, and then in the male group, starting from boat, the largest BMI is 50, and then 39, 37, 34, and then smallest one is 12. All right. Did everyone get the same result?
Has everyone got the results? Yeah, of course.
How about
Just go
online
back
people?
to code for a second so we can see it.
Yeah.
Yeah, I'll just put it up.
Okay.
There we go. This one. Has anyone had any error messages come up? Do you know what the error is, or do you want to?
recording myself. Yes, I am.
Anyone else got any error messages that don't make sense or do make sense but aren't going away? Nope. Everyone's answers look like what they're meant to look like? And what is it different?
So that's what we want.
Mm-hmm. 87. Did you do the NA omit? Yes. Cool. Let's have a look. If you do your view and you look at the data frame, are your NAs omitted? Oh, cool. If anyone copied and pasted, you'll need to delete all quotation marks and rewrite the quotation marks because it won't copy across correctly. Likewise, just check your spaces and things like that.
Yes. The quotation marks when you copy from PDF or PowerPoint, it looks a bit weird. Just delete and then enter it again. This is the quotation mark recognized in RStudio. If it's too curved, too nice like this, that's not the right format.
Also, for everyone on Windows, Control-Enter runs the line. So just in case you haven't been doing that. Any other weird issues coming up? No? All good to move on to the next step?
Okay, let's keep going. All right, this is the most important thing I think for today, because I'm pretty sure you will need some of them in your first assignment. Not as complicated as this one, but probably some of them. Right. And then we come back to this one, long and the wide format, probably in the end if we have time. Right. Let's move on to next one, which is numerical summary tables. So once we get data, we want to analyze. There are different ways to summarize data. To get information out of the data, one way is to calculate some summary statistics of the variables or multiple variables. The other way is to visualize it. Next week, in the next 2 weeks, we will talk about statistical graphs. But today, let's just talk about summary statistics, how to get a summary statistics out of data using RStudio. Now, it's quite straightforward, to be honest. So we have known the first one already. It's called a summary, which is a basic summary function in R language. It's not part of RStudio. Yeah. So summary is a base function in R. It's not part of RStudio. Sorry, not part of tidyverse. Okay. And then if you put a data frame name in there, it will calculate summary statistics for every single variable. If it's a numerical, if it's like a numbers, it will calculate this mean, maximum, median, the quartiles, and also least number of missing values. Okay, yeah. And if it's a factor, it will calculate the frequencies of each category. Okay, yeah. And if you want to just summarize one variable in the data set, it's okay. Just write the data set name and then dollar symbol and then variable name. Okay, let's do it. So you can use whichever data frame you want. So I'm just using the first of all, I'm just have a copy of the Star Wars. Star Wars. Okay, I just make a copy called the SW, which is just a copy of the Star Wars raw data. Okay, the messy raw one, 87 observations, 14 variables. And then if I summarize, I've seen this before. If I type summary SW, Control Enter, we get this output in our console. It's messy because we have a missing value or something. Okay. Yeah, we get this summary of each variable. Okay. Yeah. Otherwise, you can try summary SW underscore need, the one we just processed. We get this summary and SW underscore need. We get a summary of each single variable. Okay. Yeah. And then if you just want to summarize one variable, summary SW dollar symbol, let's see, mass, which is body weight. You get a summary statistics of this single variable mass. Minimum, maximum, first quartile, third quartile, median, and mean, and the number of missing values. Yeah, okay, nothing complicated. All right, and then if you want to summarize a bunch of variables, you can use the type operator again and the select operate function in the tidyverse. Okay, so once we have a tidyverse already loaded, library tidyverse already, so we can do this. You can type SW type and then select these three variables, height, mass, sex, and then summary. Okay, and then you will see these three little tables. Okay. Try, it should be working. Run. Yes, it worked. It worked. Okay. Yeah. So it's quite flexible. You can see using the tidyverse vocabulary and functions, it makes your analysis much more efficient. Yeah. Any questions? Good. All right. Okay. Now, yeah. Now, if you use now this part is a little bit important here. Okay. So once we have a tidyverse loaded, we can use the group by function and the summarize function in tidyverse to make some to create some summary statistic tables. So remember, summary is the base R function. You don't need tidyverse to do it, but summarize is a function inside tidyverse. You need a load tidyverse to use summarize. So what do I do here? So first of all, I'm going to create some summary statistics. Of this data set SW, which is the copy of the Star Wars raw data. So what do? So for this data set SW, I'm going to drop the missing values in height and sex. Okay, I'm going to drop the rows with missing values in either height or sex or both. Okay, and then I'm going to group by sex. I'm going to analyze for each sex group. So group by sex, group underscore by sex. Okay. And then summarize. I'm going to summarize height for each sex group. Okay, so that's why I put the group by sex here first, and then summarize. This is the calculations of height, all about height. Okay, so what did I do? I'm going to calculate the minimum value of height, maximum value of height, the average or simple mean of height, and also the range of height. The range is the maximum minus the minimum, and then the standard deviation of height. SD means standard deviation for each sex group. So for group by sex, and then for each sex group, I'm going to calculate the mean, maximum, mean, the minimum, maximum, mean, the range, the difference between maximum and minimum, the standard deviation, and the number of observations count for each sex group. Okay, yeah. So I put all the stuff in the summarize function, and then I give each calculation a statistic, a name. The minimum of height, I call this one low underscore height. Maximum, I call it up underscore height. You can name whatever you like. And the mean, I call it average underscore height. And then the range, I call this one height underscore range. And the standard deviation, I call it SD underscore height. And then the frequency of observations in each sex group, I call this one count. Okay, so you can see and then I rearrange the output. I'm going to present the table in the descending order of average height. And then if you view the results, you will see this. So this will be the output of this code, bunch of code. So I have a sex group, male, female, and a herm, blah, 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 something. And then I have this 6 summary statistics I requested before regarding height. So low height, up height, there's the minimum, maximum, average, the range, standard deviation, and the missing value. Sorry, number of observations, not missing value, number of observations, which is count. Yeah. Okay. Yeah. So we have a 66 male observations, 150 female observation, and 175 hermaphroditic something. Sorry, not. That's the minimum value of height. We have in terms of observations. Look at count. We have a 57 male characters, 15 female characters, and only one hermaphroditic character, which is something I know. In the Star Wars, and then for each sex group that we have the minimum, maximum, and the average. Now, if you only have one observation in the group, the average is itself, and the range is 0 because there's no range. There's only one observation in the group. There's no range, and of course, if there's only one observation in the group, there is no there's no standard deviation, right? Yeah. Because there's no variance. Standard deviation is a measure of variation. If there's only one variable, I'm sorry, if there's only one value, one observation, one case in the group, there's no variation. Of course, the standard deviation and variance is 0. You see missing value here because we are calculating the sample standard deviation. So when the sample size is 1, you can't calculate the sample standard deviation because remember the formula of sample standard deviation? You have to divide the sum of squares by sample size minus 1. So 1 minus 1, the denominator becomes 0. So it cannot be calculated. Okay, for sample standard deviation, it cannot be calculated when the sample size is only 1. Yeah. All right. Okay. In the lecture, you talk about the meanings of the formulas, but today we only talk about how to get them in RStudio. So let's run this one, see if we can run. So highlight everything. Go to RStudio. then find some empty space in my R script. Then I Control-C, Control-V. So this is, make sure you put the irrelevant comments in a line starting with a hashtag. I will make this a comment with green. Okay, so first of all, SW Star Wars data, and then drop the missing values in either height or sex. So as long as a row has missing value in any either one of the two variables, that row will be dropped, will be discarded. And then we're going to group our report by sex group. We have 3 sex groups, male, female, and a hermo for big something in the Star Wars context. And then summarize, we're going to summarize a bunch of the data in each sex group. We're going to calculate a bunch of statistics about height. So minimum, maximum, mean, the range, and the standard deviation. And then at last, we request the number of observations, the sample size in each sex group. And then I gave this 6 statistics of height, 6 different names, low height, up height, average height, SD height, and then arrange the output by descending order of average height, and then view. Okay, so highlight them, run. Voila, we got this result. Hopefully you get the same result too.
Anyone got any different results? Cool. Good job.
This time it should be easier because there's no double quotation marks in the code. Every time there's double quotation marks in the code, it could be something annoying. Yeah, luckily there's no double quotation marks here. Yeah, so you can hear we just created a new data set because when you view it, you can see there's a new data set here. Of course, you can copy and paste this into your report, maybe further format the table using the Microsoft Word text editor. Yeah. You can also just assign this whole thing into a new object, I guess. So we can call this my name, like height stats. I stats. Okay. So let's see if it works. I'm going to create a new data frame called the height stats by sex, and then it will come from this bunch of operation. So let me do it. Right. Did it work? Oh.
I recommend assigning it to an object in all your assignments. So when you're doing graphs and tables and everything, whenever you're producing something, make it an object, because then you can easily recall it later. So it'll make just putting your reports together a lot more simple. So yeah, basically never ever run just plain code unless you're just testing something.
Yeah. Where should I assign this object? Should I put it in beginning or in the end?
Beginning, I think you'll just need to copy the name and then run the name alone as well.
So I just call it as a table?
Yeah, and then
Table 1? Like this?
Yep, and then down the bottom, if you run that.
Okay.
And then down the bottom, just write table 1 and run table 1. They'll appear.
So I just highlight and run?
Yep.
But I didn't see that before.
And then in line 47, if you just write table 1.
Okay, table 1.
And now
I'm
run
going to close this one. So table 1
and run.
and run. Probably control enter. Table 1 doesn't found.
Fun. Oh, I think it's just spelled different. Oh.
Yeah, because if the table 1 is created successfully, I should see the table 1 in the global environment.
Maybe the maybe undo the pipe at the end of the view, before view.
Yeah. Yes. You can't end your piece of code with pipe operator because it tells you still want to do something. So if I want to assign this whole operation or piece of code of processing the creating the stats of height into something called table 1, I need to end before this last operator, because remember at the beginning, before we had after arranging data and then we view the data. So now let's say I don't want this. I'm going to put a hashtag there, and then I'm going to do the same thing, SW, which is the original copy of the Star Wars data, and then do the dropping missing value rows, group by sex, summarize height with a bunch of statistics, and then rearrange this data output table by descending order of average height. You see, I didn't highlight I comment out the last pipe operator, which I used before to connect this step and then view the table. So I just highlight this bit and then comment out the last pipe operator, and then I'm going to assign this the output table to an object called table 1. Hopefully this time it runs. Yeah, we got table 1. The table 1. Yeah, thanks, Lydia. And then if I so now you can output your you can save the workspace or project into a project folder, and then you load the workspace again. Next time the table 1 will be there in your working memory of the PC. And then if I view table 1, you see this result again. Right, yeah, and then as Lydia said, it's always good to save your output of table or visualization as an object, and then you can save the object and then reload it next time if you want to use it again. Yeah.
And the commenting out can be really handy as well. So like this, if you've written this whole bit of code, for example, and then you don't need it and you're running the whole document consistently, commenting it out is an easy way to retain the work you've done without running it. So
yeah, the comment
something to keep in mind rather than just deleting all the work you've done. If you comment it for your records.
And it's also handy in future when you are debugging your code. Sometimes you want to just skip some lines of things. Okay, suppose I say I don't want these 3 things. For example, and then I don't want to delete them. What do? I can comment them out with hashtag in front of each line. Otherwise, you can highlight the 3 lines, and as I mentioned before, you go to code, comment and uncomment these lines. Code. You can switch between comment and uncomment multiple lines in one go. Yeah. All right. So why this part is important, because I guess in the first assignment you have to use the group by and the summarize functions in tidyverse to create some table of summary statistics for your first assignment. Yeah, so you can basically do the same thing as here, as we did here. Okay. All right, and okay, then I talk about like a contingency table. So suppose we want the table of a sex by size. So let's work on the SW need data we created previously. So To create a table, a contingency table of two categorical variables, in this case, sex and size, is very simple. Just type table, and then the two variables in the data frame, and then we can assign the table to an object. Okay, yeah, so. So you can see here, if I just type table these two variables and then run, I will see this little contingency table. Okay. I put the sex first and the size second. So sex will be in rows, F and M in the two rows, and then big and small in the two columns. If you type table SW underscore need $ size, and then sex in the second, the size will be in the rows and the sex will be in columns. Again, I can give this one into an object, as we did before. I call this table sex by size. Okay, and I can assign this one to a table, and the new object of table will be created here. Sex by size.
All following so far?
And then if I want to use it again, I want to see it again, and just type sex by size, and then. And then you can have the marginal total by this. You can type margin.table. The table name, and then if you put a 1 here, you get a row totals. You get a 2 here, you get a column totals. Yeah. Margin.table sex by size. That's my table name, and then you put a 1 here. You request the row marginals. If you put 2 there, you request the column totals or marginal. First one, 9 female, 44 male. Yes. If you request column totals, 33 big and then 20 small. Right. You can also request the proportions, the percentage of the cell in each row or in each column or in the entire table. So you can try yourself. Yeah. So if I put a proportion.table and then put a table name there, I will calculate the percentage of each cell in the whole table. So 0 divided by the whole table, which is 33 plus 11, which is 44, 44 plus 9, which is 53. Yeah. You can double check. If you divide 11 by 53, if I divide 11 by 53, it should be 20% something, 0.2075. That's this value. Yeah. And if you put a 1 there, I will calculate the row proportions. So this 100% comes from 9 divided by 9. Yeah. 75%, 25% that comes from 33 divided by 44. That's the total, and 11 divided by 44. And if you put a 2 here, it will calculate the column proportions. Okay. Yeah. All right. Any questions? It should be straightforward this part. Okay. And if you don't want this step-by-step thing. I tell you, there's a shortcut. If you install this package called the G models, and then use the package G models, there's a function in G models called a cross table. And then you just put the two variables you want, and the cross table function in G models will spit out this big massive contingency table along with a bunch of summary statistics. Yeah. If I zoom in a little bit. Yeah. But you have to install this package and then library it out. It's called the G models, lowercase g models. Yeah. Install it, library it out, and then there's a function called a cross table in this G models package. Just type G models brackets and then the data set name, variable name, data set name, variable name. So again, we use sex versus size, sex in the rows, size in the columns. And then we have this massive contingency table. It's a 2x2 table, 2 sex groups, 2 size groups. And in each of the 4 sides, you have this information. Number of observations, that's the n. You see the cell content? The first net value is the n. Frequency in each cell, I have 9 small female characters, okay? And then 11 small male characters in the data set, okay? And then chi-square contribution, you can ignore that. That comes from chi-square test. And then when you see the proportion of n divided by row total, 0, 1, 75%, 25%, yeah. And then the fourth one is a proportion of column. And the last one is a proportion of the whole table. Yeah. So you can compare the values from there and here. It should be the same. Yeah.
Is everyone able to install and load G models all right? Yeah. Cool.
Good. Yeah, it's just handy. You may or may not need to use it. Just when I was writing this slides, I just think, oh, maybe I should need to tell you the quick way to do it. But there could be even a better way to do it these days. Who knows? The packages are new packages are being released and updated every day. All right, and then we have a bit more time. Further two-way cross tabulations. So we talked about the contingency table on previous page. Contingency table along with the cell statistics. We can all use two-way cross tabulation or cross tabs to summarize data in the way we want. Again, we're going to use the group by function and the summarize function in the tidyverse package, which is quite similar to what we did in here, if you still remember. Yeah, it's quite similar to this one. So like this one, suppose I want to calculate the frequency of the groups by sex and size. So SW need and then group by these two variables, categorical variables, sex and size, and then summarize. So in summarize, you put the stats function you want. So n empty brackets, that's requesting the frequency. So n, lowercase n, and an empty pair of brackets, that's requesting the frequency. It doesn't look very good because you see we have a male, female, and then let's do it now. I'll tell you. We get this. But we know that it will look better in a cross table. So how to make a cross? You have to spread size. Format a cross table. So this is kind of an alternative way of getting the one we get before in here. You can use a table function, or you can use the tidy words group by and the summarize function. But I think in this case, the simpler way is better. the size by the table function in the base syntax. Yeah.
Have you all written that code though? Because they'll be handy for the next step. Yeah.
Different from here. Okay. So you remember in the previous slide, in this slide, we summarize height according to the sex group. Okay, we have 3 sex groups, and then we summarize the height for each sex group. Yeah. But in here, we are going to group the data by 2 categorical variables, sex and size, and summarize BMI for each group. So we have 2 sex groups, and then 2 size groups. So there are 4 groups according to the size and sex group. And then we calculate this maximum BMI for each group. That's the difference between this example and the example we used for height before. To give a try. So remember the title of this page is a cross tabulation, 2-way cross tabulation. So you need 2 categorical variables to create a 2-way cross tab. Categorical variables means the variable is either nominal or ordinal scale, like sex and size. Sex is nominal, male, female, and also some other like a noun or other category. And then the size here you can think of as an ordinal, big, small. So you need 2 categorical variables anyway to create a 2-way cross tabulation. 2-way means 2 categorical variables. One is sex, the other one is the size in this case. And then after creating this 2-way cross tabulation with 2 categorical variables, you have multiple cells in this cross tabulation. So in this here we have a bunch of sex groups, a bunch of 2 size groups. We have multiple cells, and then in each cell, in each combination group, you can request whatever statistics you like of whatever variables you want to know. So here in this sex by size group, cross tabulation, we calculate the maximum BMI. Okay. The second example here, in each of this combination of sex and the size, we calculate the average of weight in the SW data set we created before. Yeah. In practice, I think two-way cross tabulation that is used a lot. Of course, you can also make your table more complicated. You can involve 3 variables in the cross tabulation, but I don't think that's easy to read. This table is 2-dimensional. It faces 2 variables, one in the columns and one in the rows. If you make the table too complicated, it's just too hard to read. Yeah. Let me give a try with this one. Should be working.
I think in a science degree, understanding the different types of data, what you can do with them, how you collect them, how they work is probably the most important thing you can have. So make sure if you don't already, you're putting in extra time. So understanding not just what's the difference between nominal and ordinal categorical data and continuous and discrete numerical, but how you collect them and how that affects your data analysis. So yes, because obviously different combinations of them produce different results and tell you different things within an experiment, for example. So yeah, when you're doing all this stuff in SCB 113, it can feel very abstract. So really be like trying to focus on the purpose of what you're doing and think, how could you apply it in your specific major or to a different context, so that in your future units, you'll be able to easily identify and remember these skills and apply them correctly.
Yeah, thanks, Lydia. Definitely the skills you learn in this unit or subject will be used in your future semesters, right? Yeah, and particularly if you are going to do an honors or research degree, definitely will be part of the work, data analysis. So when you're analyzing your data, like when you're trying to analyze your data or summarize your data with a table or statistics, or use graphs. In the next 2 weeks, we talk about graphs. You need to have something in mind in your in your brain, like what I want to get, what question I'm asking, what information I want to investigate, what comparison I want to do, or what trend I want to trace, and then you think about, okay, how do I obtain this graph or obtain this summary statistic table using RStudio or any other software package or Excel or something like that. Yeah. So if you just do things without knowing what you want, you just randomly get graphs and tables. That's the waste of time. Yeah, and then you feel at a loss. Feel lost. Don't know what you are doing. Yeah. So you need to have something in your mind. Okay, like what I want to compare. I want to compare the height between the sex groups, or I want to compare the height between the groups in combinations of sex and size, and then you can create a two-way cross tabulation by sex and size categories, and then in each combination, in each cell of the two-way cross tabulation table, you can request the maximum of height, and then the average of height, or whatever you like. Yeah. Yeah. And then this last page is just like as I mentioned before, it's always good to assign your output of table or graph into a object, and then you can load it again. And just quickly show you, of course, RStudio and R can create graphs, and then we talk about more graphs in the next 2 weeks. Just show you a little quick game here. So let's see. let's plot something here. Let's have a scatter plot of SW. What did I use before? Height and mass. Okay, body height and body mass. SW need height and SW need mass. No mass in there anymore because it's the weight. Yeah. So the plot function in the base R language will create a XY plot or scatter plot. And then if I run this one, you should get a plot in the bottom right corner. If you see an error like this, error in the plot, the figure R margins are too large, that means your bottom right corner is too small. You need to make it a little bit larger for the graph to show up. Okay. If you're using a big desktop, it's probably not a problem. But if you're using a little laptop with a tiny screen like mine, you may have the problem. So make it a little bit larger. Okay, bottom right corner, because the graph will show up here. The plots will show up here, and then highlight, right? This is graph. So x is a height, horizontal axis, and then y is a weight, the vertical axis. And of course, you can export your graph as image or PDF, or just export to your clipboard. And here you can adjust the scale. Okay, make a little bit of tall. I mean, make the height be larger, maybe 300. Okay, and then I can open a Word document. Paste it. Doesn't work. Again. Clipboard. 300. Update preview. Oh yeah, I didn't click update preview before. Okay. Looks a bit better. You can see as the character become taller, the body weight becomes larger. Generally, kind of positive linear relationship. Okay, and then you can copy your plot. Copy, and then go to my Word document. Control V, paste. Plot here. Okay. Of course, this plot is probably too simple or too raw, not very beautiful. But don't worry, we will learn about how to visualize your data or create statistical graphs properly using a package in R called the ggplot2. That's a package of data visualization based on the grammar of graphics. We'll learn that in the next 2 weeks. Okay. Yeah, this little game here, I think I just put it. Let's give it a try. This one. I don't know why I put it here. I just like the game. I think let's give it a try and identify. I think it's kind of something interactive. So highlight this line and then run.
Will the mass have to change to weight?
Yeah.
An SW neat.
Yeah. I think this identifier function is kind of something interactive. Once you run it, obviously this plot is not very good. Maybe using this one. I think because my bottom right corner is too small. Make it a bit bigger. Yeah. Can you see that? So once you run this identify function, it will, once your mouse clicks somewhere, it will find out the recent data points and then label their names. It's just a little game. It's nothing really important. You won't need it anyway. Just some little game. You can see we can do many things in RStudio. Maybe we'll learn how to properly make statistical graphs in the next 2 weeks using ggplot. That's important because you are required to use ggplot to create graphs in all your assignments. I'm pretty sure about that. Yeah. And then ggplot is very, very powerful. Lydia probably knows that in science. When you analyze data, when you want to create publication quality data visualizations, ggplot is probably one of the best choices. Much better than the basic plot functions or whatever in the basic R language. So let me quickly just remind so again, I will email you the copy in the end. Also I get a copy already. I will email the links. Just remind you to fill the attendance form and feedback later this afternoon. And so we have a bit more time, so I want to quickly go through this one. So I just noticed that in your workshop, in your R workshop, in SE113, they also talk about the reshaping of data between long format and the wide format. So I just quickly add some slides here. We may or may not have time to go through the details. I don't know if you need to use it or not in your assignment, probably not. But I just want to mention that normally we can analyze. So sometimes we analyze longitudinal data. That means you measure or follow a bunch of individuals over a time period. So you measure them not just once, you measure these individuals multiple times. So for example, here we have a data set called the gapminder in R. It's a measure of 142 countries, says population, GDP per capita, and the average life expectancy every 5 years over the period of from 1952 to 2007. So every 5 years over this 60-ish years, we have 12 observations per country on those on those 4 variables. So we have 142 countries. We measure their population, GDP, life expectancy every 5 years over 60 something years. So we have 12 observations per country, and in each observation we have the country's name, of course, continent. Look at here, the year of observation, and the life expectancy, population, and the GDP per capita. Yeah. This is how the data is organized in this gapminder package. So if you like, you can install this package and then library out, and then have a view of the data. So if I do that, I'm pretty sure I've installed them already. So I'll just library it out. Yes, this is the gapminder data. I just made a copy of called the GM. You can see we have a countries, the continent of the country, the year of measurement, and then the 3 variables: life expectancy, GDP per capita, and then also population, POP. So the first one is Afghanistan. I think it's ordered alphabetically. Afghanistan in Asia, we have a 1, 2, 3, 4, 12 observations of Afghanistan, and then the next 12 will be Albania in Europe, Eastern Europe. Okay, something like that. So this way of organizing longitudinal data or repeated measures, we call this long format because it's long. It's long format. Okay, so we have a multiple rows of each individual, and multiple rows for multiple measurements and multiple time points. Yeah. The other way of organizing longitudinal data is called a wide format. So basically, we put the measures into different columns. So each observation has, sorry, not observation, each individual or subject has only one row, but we put the multiple measures at the multiple time points into multiple columns. Okay. Yeah. So if you look at Ben and Jess, we have 2 measures for each person in different years. This is long format on the left, 2 rows per person, and this is the wide format. Okay, we have 1 row per person, but we have 2 columns for height.
Knowing which you're using as well is important. A lot of data you'll collect in the field, if you're doing like experiments, will come in like wide format, but a lot of times ggplot, for example, works better using the long format. So
Yeah.
being able to like switch between them and stuff is important.
Yeah, so each function has a sometimes the function requires wide format, sometimes the functions requires long format. Yeah. I just realized I missed the year here. Missed the variable year. Yeah. All right. So how do we convert between long and wide formats? We can use the tidyverse function. The function called pivot wider. That we can use that to convert or reshape the data in long format to wide format using pivot wider. So you make the long format data into wide format data. It's a little bit complicated. So if the code is very simple here, but the meaning of the code is I put it here in the sentences. So first of all, you need to tell pivot wider the function which variable is the time point variable. Okay, for us that's year. Yeah, because we have 12 observations over 12 at 12 different years for each individual. So the names from this variable year. Okay. And this year, the values in the year will show up in the future columns names in the wide format. And then we tell the pivot wider function, okay, which variables you want to make it wider. So for us, that is life expectancy, population, and then GDP per capita. So basically, we will have 12 columns for life expectancy at different 12 years, and 12 columns for population at different 12 years, and 12 columns for GDP per capita at different 12 years for each individual country in the original data in the long format. Yeah. And then if you run this line successfully, you will get this. So now we have one row for every single country. It should be 142 rows. Okay, and then we have the data set will be very, very wide because we have a bunch of variables. We have 12 columns for each of the 3 variables: life expect, population, and then GDP per capita. And if you double check the dimension of the result, it should be 142 countries, 142 rows, and then 38 variables. Okay, 12 variables for each of the 3 variables. So 12 minus 12 times 3 is 36, and then continent and then country name, 38 variables. Yeah. So that's how we pivot a long data into a wide data, which is easier than doing it the other way. So how to do it the other way? I put it on the next 2 pages. You can give a try if you have time. I'm not quite sure if you need to use it. Hopefully not. So how to make the data longitudinal data in wide format? and then convert into a long format, of course, you can use a period longer function to pivot the white data into a long format. Use a period longer function. Again, it's a little bit more complicated. We use the same example. So now we can pivot the white data we just created back into the long format. Okay, so it has two steps. First of all, you use a pivot longer function here to pivot the white data into something like this. Okay, you need to tell what are the columns you want to pivot the data in white format into long format. So that for me, that's column 3 to column 38. Remember here, column 3 to column 38. And then you have to tell the names too. You need to create a name for the time variable. For us, that's year. Okay, and then retrieve your vehicle. Very well served. Your vehicle awaits. And the values of those data in long format. And that's the first step. And the second step, you have to reorganize the data. So
Any questions?
Oh, now function suit. It should be correct this time.
The code's worked for everyone? No errors? Cool. Good job.
yeah, you can give a try. If it works, I hope it works.
Yeah, it's working for everyone.
It works. It worked for somebody. Have somebody tried? Yeah.
Yep.
You can see the period wider is easier, but period longer has been more complicated because you have to figure out, okay, the time point variable, for us is the year, and then how to organize the long data into the original 3 variables. But again, I put example of codes here. If in case you need to do that in your own data set, feel free to modify the codes I put in the slides.
But first,
hopefully it works, but who knows? That's the fun of coding. But of course, there are also other packages, statistical packages, that can do this work. The shaping, the conversion of between long and the wide format of data, not based on syntax, based on some graphical user interface. Just drag and then name something. That's probably easier to use. I know some packages can do that, definitely. For example, SPSS. But the R can do that with syntax, and then R can shape a huge amount of data much faster than some other packages. Like I think, yeah. All right. That's all for today. Definitely. And it's already 10 to 12. So I will email you again the links of the recording and also the links to the attendance. So if you have time, please do the attendance form and the feedback. It won't take you more than 2 minutes. And then I need to. Do you have any questions for me or Lydia?
About the workshop or your ICB 113 assignments, anything? No. All good.
Oh, good. And Lydia, you'll be here again next time, hopefully.
Yes. Yeah,
Yes.
should be good for the rest of
Okay.
Sem.
Yeah, feel free to have a chat with Lydia. And then I need to wind up this one, and then I need to rush back to QUT again, give a try. Hopefully there's a parking, and because I have another teaching, I definitely have to be in the room at 12:30 to 2. So thank you everyone for your patience this morning, and then I will email the recording afterwards. Thank you, Lydia, very much for your help. You saved the whole workshop this morning.
All good.
Yeah. Okay.
Thanks,
Thank you.
everyone.
Bye bye.
Thank you.
Bye-bye. Thank you. Stop recording.